In this video, we're going to continue looking at finding derivatives of functions and using our new rule, the chain rule, to help us find those derivatives. So let's start off with this example here. If y equals 1 over 3x minus 2, we want to find the derivative of that. Now, I'm starting off with this one first because there's actually two ways we could find this derivative. This is a quotient, so we could use the quotient rule. So let's try that. Let's say use quotient rule. So that means y prime is going to be the bottom, 3x minus 2, times the derivative of the top, which is 0, minus the top, which is 1, times the derivative of the bottom, which is 3x, which is just 3, sorry. All over the bottom squared. 3x minus 2 squared. So that means y prime is going to be negative 3 all over 3x minus 2 squared. Okay, so now let's use the chain rule. Now if y equals 1 over 3x minus 2, we can rewrite this to be y equals 3x minus 2 to the negative 1 power. So then that means y prime. Okay, now because this is a chain rule, the inside part is 3x minus 2, the outside part is to the negative 1. So we bring out the negative 1. Negative 1 times 3x minus 2, and then we subtract 1 to the negative 2. And then we take the derivative of the thing inside, which is 3. And so we end up with, well, we have the 3 and the negative, so it becomes a negative 3. Because it's to the negative power, we rewrite this in the denominator, so it's 3x minus 2 squared. And so we end up with the same answer. And I mean, in this case, it's almost just a preference. Do you like the quotient rule more, or do you like the chain rule more? And I'll let you know, I tend to like the chain rule more for whatever reason. I sometimes make a mistake on the quotient rule, so I try to avoid that when I can. But the chain rule, I always seem to do okay with. So I actually tend to go to the chain rule. However, if you figured this out using the quotient rule, there is nothing wrong with that. It is the correct answer. Let's do another example of kind of rewriting to use the chain rule. So back, I don't know, last section or something, we had this. If y equals the secant of x, we want to find y prime. Now to find the derivative of the secant, we first rewrote it in terms of, well, in this case, cosine. So we had y equals 1 over the cosine of x. And when we took the derivative, we only had the quotient rule, so we used the quotient rule for that. But now let's see what happens if we use the chain rule. So we could rewrite this to be y equals the cosine of x to the negative 1 power. And now we can take the derivative of this. So y prime, so remember the inside is the cosine, the outside is to the negative 1. So we bring out the negative 1, so we have negative 1 times the cosine of x to the negative 2 times the derivative of the thing inside. Derivative of the cosine is a negative sine of x. And so we end up with a sine of x over a cosine squared of x. And of course we ended up rewriting this to be the tangent of x, secant of x. But it's the exact same answer we came up with when we had the quotient rule. So for these examples, sometimes when you're looking for the derivative, you do have a choice on how to find that derivative. And as long as you follow the rules and of course don't make a mistake anywhere, you will come up with the same answer. All right, let's try another example, and in this case, there's no rewriting. We have one option. Let's say if y equals x times the square root of x squared plus 1, and we want to find y prime. Okay, so this one, we have a product rule, and then we have a chain inside the product rule. So we have a couple things going on. So first I'm going to rewrite it. Y equals x times x squared plus 1 to the 1/2. And so when you have two rules at the same time, we're going to have a product rule and then a chain within a product, you just kind of have to keep track of what's going on. So let's take this derivative. So y prime is going to be the first times the derivative of the second. Now this is a chain rule, so we have the inside part, which is x squared plus 1, and we have the outside part, which is 1/2. So when we take the derivative, we bring out the 1/2, so we're going to have 1/2 times x squared plus 1 to the negative 1/2. Okay. And then we take the derivative of the thing inside, which is 2x. Okay, so we had the first times the derivative of the second plus the second, which is x squared plus 1 to the 1/2 times the derivative of the first, which is just 1. Okay, now we need to clean this up. So let's see here, we get y prime. These 2's cancel each other out, and so we end up with x squared all over the square root of x squared plus 1 plus the square root of x squared plus 1. Alright, let's go ahead and combine these fractions. Now in order to combine the fractions, we need a common denominator. So we're going to end up with y prime equals x squared all over the square root of x squared plus 1 plus, and then we're going to have to multiply the numerator and the denominator by the square root of x squared plus 1. So we have the square root of x squared plus 1 times the square root of x squared plus 1 all over the square root of x squared plus 1. So we multiply the numerator and denominator by the square root of x squared plus 1. So then we end up with y prime is x squared over the square root of x squared plus 1. And then let's see here, we have this times this. Well, we're going to end up with the square root of x squared plus 1 squared. So it's just x squared plus 1 all over the square root of x squared plus 1. Okay, so now we can combine these fractions, so we end up with x squared plus x squared is 2x squared plus 1 all over the square root of x squared plus 1. And there is our final derivative. Okay, so of course we had a little bit of algebra to do, but here's our problem. We had x, we had a product rule, then we had a chain rule, so we had to find the derivative using both the product and chain rule.